Hello everybody, we are back for another week of Adventures in DevOps, and today we're going to talk about logs and log streamings, and I don't really know a whole lot about that topic, so we're going to kick it right on over to the guest, as we like to do. So with us today we have Chris Cooney. Did I say your name right?
Yes, ma'am. Perfect.
All right, great. Will Button and Jonathan Hall.
Hi, I heard we were talking about streaming. This is all about Twitch, right?
Yes, video games, Twitch, the new Zelda
Awesome.
game, that's it.
That's why I'm here.
Me too. All right, Chris. So with that, completely derailed your topic for a moment there. Why don't you tell us a little bit about yourself and whether or not you play video games and how that relates to streaming?
Yeah. Okay. It's quite a challenge. Unfortunately, I'm now the guy that's not talking about gaming, which is the worst position to be in. But so I'm Chris. I've been a software engineer for 10 years now. I began my career as a Java engineer, and then which was fun. And then I moved into sort of front-end engineering, React, Angular, that kind of thing. And then eventually ended up maybe 4 or 5 years ago getting into the sort of SRE and DevOps space. Primarily worked on serverless architectures and Kubernetes, very heavily on the Kubernetes space, building internal platforms. And I ended up becoming the platform engineer the principal engineer for platform engineering in a retail company here in the UK called Sainsbury's. So it was a big company, 2,000 engineers plus a bunch of maybe 1,000 contractors, about £1 billion, $1.3 billion annual online business. So a lot of traffic, a lot of stuff, and a high regulatory requirement as well. So that was all the sort of work I was doing at Sainsbury's. Now I am out of the retail space, which is nice, and I am working with Coralogix. Coralogix is a full stack observability provider. So we process logs, metrics, traces, security data, and we render that in new, fun, and interesting ways. And we hope to, the big things that we're focused on challenging is breaking data silos. So people typically look at their logs, all their metrics, all their traces, all their security data. And what we do really, really well is we blend the experience together. So you can jump from your logs to your metrics to your traces, and you can kind of move between them really fluidly, and helping customers deal with scale. So helping them challenge sort of approach the challenge of you have a vast amount of data. Holding on to all of it is extremely expensive. How do you archive it? How do you store it, compress it, do whatever you need to do with it? And moreover, how do you do that in a way that's completely accessible, using the lowest cost storage, but maintaining very highly performant and effective queries, and maintain data discoverability. So it's a big sort of space that we're in. And the reason for the topic today is that one of our big differentiators, we're built on a streaming-based architecture. So using Kafka streams. Unfortunately, the Twitch streaming kind, so sorry to disappoint anyone who's excited. And as an ancillary topic, yes, I do play games. Hence the chair for anyone who's watching the inevitable video. I believe that the gamer's chair is like a signature that someone spends too much time in front of a computer, getting angry over certain scores that don't really mean anything, which is a somewhat pessimistic way of describing gaming.
So I think it might be useful to define what streaming means in this context.
Yeah.
Because I mean, we're talking about logs, right? What other way of logging is there than streaming it? So help me understand what we're talking about.
So there's it's logs, metrics, traces, and security data. It's the full sort of gamut of observability and telemetry data that one might expect. So the typical approach that most companies take is you send your data to them in some way, so via an API call, via some sort of queue that's sent, Kinesis or whatever, and then they take it, they store it in a giant data store, they will index it, they will try and rationalize it, normalize it, make some sense of it, and then they will trigger downstream alarms, they will update metrics, they will update dashboards, they will train machine learning models, they will do all these things. But ostensibly it's ingest, store, index, and then process. This is a pretty normal data processing model. The problem with this model is twofold. One, maintaining this giant store at the start is really difficult. It actually means, just from a pure economics point, the cost to ingest a given byte of data is higher if you go with this model, because you've got all of the additional processing that's associated with indexing and querying those indexes and rationalization, normalization. And this is if then the customer might decide, actually, I just want to drop this data. It's really, really common for this. And actually, block is often a delete process. It's not actually a don't store this in the first place. It's actually a delete process because the companies are simply architected to store up front. So the way streaming differentiates from that is that in the example of Coralogix is you ingest data into Coralogix, immediately it goes into a stateful Kafka stream that has persistent backups. This enables a few things. One, really, really early and very fast decision making. So if you don't want data, it will never be stored. It will never be held in the database. It will never be indexed. No metadata will be held about it. It will just disappear into the ether. The second thing is that it enables you to make decisions about where you'd like that data to be stored. So what a lot of archiving, if you'd like, as an example, what a lot of archiving solutions do is you take your data, it goes into high tier storage or something, and then after a certain amount of time, you can send that off to the archive. Whereas actually what we found is that if data is useless or if data is very verbose and you never query it, holding it for 2 weeks isn't going to change that fact before it goes into an archive. And so what streaming observability allows you to do with that early decision making is it's been ingested by Coralogix, route it directly to your archive. And the thing that Coralogix can do differently is we can query the archive directly, and the archive is actually held in S3 in the customer's account. And so you can query the archive directly and without having to reindex or decompress or anything like that. And so these are all things that are enabled by a sort of stream processing based architecture. And there's a series of non-functional things as well that aren't necessarily for the customer. So for example, if you do a store first kind of approach, if your storage dies, you're in trouble. You're in some serious trouble. You lose pretty much all your features straight away. And if storage layers can be temperamental, they're also the scariest part to change in almost any architecture is the stateful parts, because if they get corrupted, if the memories goes wrong, or if the actual drives die or something, you're in serious trouble. Whereas so if your storage dies, it kind of goes. With a streaming-based architecture, all of that processing happens up front. Storage kind of happens at the end. So your alarms will still fire, your machine learning models will still train, your dashboards will still update, your metrics will still be generated. And then if the storage layer does have a problem, it might not be stored at the end, but all of the key features along the way are still functional. So it's much more resilient, much less reliant on centralized storage. That kills that single point of failure that might exist in a sort of storage-first architecture. Just a few of the reasons. So it's more cost optimal, it's more resilient, it's faster. Alarms fire faster in streaming-based architectures than they do in storage-first architectures. So yeah, this is just some of the reasons. I obviously talking about the internal goings on in the technology in Coralogix might be NDA breaching grounds, but I suspect that I can talk about a little bit about my engineering background. We've built. So we internally, it's actually what led me to an observability company in the first place as an engineer, was we built a Kafka cluster to process a great deal of sort of stream and log data. It was mostly logs that we were trying to process. And because there was just such a volume of them coming from all these different teams and products, it was crazy. And what we found was, as soon as we introduced this cluster and we the Kafka cluster, and we added stateful backups onto the topics, all of these missing logs were no longer missing anymore. Like that just stopped happening. And we did. There was never an intention. The intention was just we just accepted a certain amount of logs were going to be missing, and that was just life. And that just stopped happening. Every single log was in place. It was never an intention. So we were trying to work out like what's going on there. And it's obviously the obvious answer now on reflection, it was really straightforward. Kafka has good mechanisms for making sure that message has been delivered where they should be delivered. And having that buffer in the way, and not relying on a central storage to constantly say like keep up with what's coming on, make it more of a pull mechanism, was much more resilient, much more consistent data. But also the volume you could push through was far higher, with a far higher quality of service that we could offer, because we were part of the platform team. We were essentially servicing 2,000 engineers. We could say to them with absolute confidence, yeah, do your worst, like set every application to trace level, it's fine, do what you want. Like the level of confidence we had in the system went way higher. And it also meant interestingly that doing things like short patching of Elasticsearch nodes or now OpenSearch nodes was far easier, because it was like, well, the nodes will go down, the queues will fill up for maybe a minute and a half. Then as everything recycles, they'll just start consuming from the queue again. And it wasn't massive message going out on Slack saying, "Hey everyone, you're going to experience massive errors," and then like having to deal with that sort of fallout. So it was just an example there where it was literally just better. Like it was just far better experience for the customers, better experience for us, fewer wake ups in the night, fewer scary deployments and that kind of thing. So yeah, it was awesome.
I want to say I like the response when like there's no data lost and things are working. What's wrong here? Like there must be some. That's like a very typical engineering response. This couldn't have worked correctly the first time.
Exactly.
Like, no way. What's really happening here?
Yeah, it was a confusion of it was a general confusion of like it was too good. It was one of them where we need to deal with the sheer number of like errors and how slow and the indexing problems and all sorts of different issues that were occurring in OpenSearch. It was like we need to fix that. Oh, we've also fixed this thing of really inconsistent and missing logs. It was like, wait, what? Like, how's that happened? And no one trusted it because we couldn't track the root cause. Once we did, of course, it was fine. And like I think because we were so skeptical at the start, it wasn't just like, oh yeah, if you put a scalable sort of cloud, like a scalable queuing or streaming mechanism before your data storage, it makes your data storage a bit more resilient. So okay, well that's relatively well understood computer science, but we just didn't trust it at the time. But yeah, it was a nice example of the before and after and experiencing that directly. And obviously when I did the Coralogix interview and they were like, hey, so we do the streaming observability thing, I was like, I know all about that. Wow. I didn't know that. It was great to see a product actually form out of that. And it's a big product as well. It's doing really well. So
that's great. That does sound much more reliable than my typical like cat log file grep. This thing went wrong.
Yeah.
So it sounds much better. Are there certain types of industries that you tend to work with?
So we tend to do best, I think, with sort of medium-sized companies. They're approaching the problem of they have too much data, and they need a sort of scalable partnership, and potentially the ones that have been burned by some of the less attractive aspects of the existing SaaS providers. So one example of this is we offer 15-second sort of support response time. So if a customer asks us a question, we will respond. Our median time is 15 seconds. We sign SLAs for 2 minutes just to be safe, but 2 minutes is still, everybody else is like half a day. We have a customer support team that will respond. We have a median resolution time of about 57 minutes, I think, this week. So it's like we tend to respond much faster. We tend to resolve much faster than people respond. And when you couple those two things together, you've got these mid-sized companies that are scaling rapidly. They're trying to find their own way. They're trying to learn how they're going to go about growing their infrastructure, growing their product. Having that kind of support is just really, really awesome. Excuse that, my cat just knocked over a card. I'm trying. This arm here is currently like cat defense. Sorry. Anyway, so the most important thing is recognizing that a lot of the customers have experienced two really unpleasant things. One is really bad support, and actually, especially with the SaaS observability solution, the support is terrible. I can't name names otherwise I get sued, but there are some big vendors out there that will leave tickets for weeks, and it's this Byzantine system of like, you have to have this specific kind of issue in order for a human being to look at it. Otherwise, you have to traverse some crazy AI bot that the intern made last summer that was supposed to save a bunch of money or something. It's nuts. So this is like one big issue. And the other one is overages. The sort of prevalence of overages amongst SaaS observability, and it's like their business model at points. It's like, well, oh yeah, they gave us this great rate, but every single year we get hit with an overage that's 5 times our base billable, and it's like, well, that's crazy. That's not really any way to do business. So we don't charge overages. And what we found is that the predictability and the consistency and the transparency of the pricing model, plus the excellent support, plus the performance, works really, really well for those medium-sized companies that are trying to scale fast and need partnerships rather than just, you one customer out of a million. And it's the same thing. The big companies now are starting to notice this as well, I think, which is really interesting. These massive companies are starting to become quite interested in some of our solutions as well. So we'll see where that one goes. But, yeah.
Cool. I guess the more you guys grow, just don't bank with SVB, I guess.
Oh gosh, no. That was terrifying. We luckily it was zero exposure for us, but it was it was. I saw that and I was like, because I don't really, obviously I'm from the UK, and I knew about the existence of SVB, but I didn't know just how like far-reaching the consequences of that would be. And then I started hearing that the Prime Minister here is, so the Prime Minister here is currently was in talks over the weekend with Joe Biden, and I think I can't remember who else, the third person. They were just trying to like make sure that people were buying off the different arms of SVB to make sure there wasn't this massive bank run that occurred. It was crazy. I never realized it was going to be that big a thing. But yeah, turns out it was. What was that like for you guys? Obviously, over in the States, was it like a national news kind of thing, or?
Yeah, I was trying to convince my husband that I should be a stay-at-home like kid cat mom. He was not going for that plan. I was like,
Okay.
yeah, might be out of business, might not be. We don't know. I guess we'll find out Monday.
What kind of pushback do you ever get when you start talking about streaming? Do you get naysayers or people who don't believe that it's the right solution? What kind of things do you hear there?
I'll be honest. I think that stream processing is still. I know Kafka is becoming more and more normalized in the industry, and more people are using it. But I actually think that most people don't really know what the difference of a streaming architecture versus a sort of stateful or a batch architecture might be. And so most of the time, actually, what we find, it's an educational challenge. It's like they're like, great, you're streaming. What the hell does that mean to us? And so that's actually, I think, would be the biggest thing that we come up against. And then and so to the point now where we run internal sessions with people who aren't necessarily technical in the company, so that everybody in the company knows like really well and really clearly what the difference is, what the pros and cons are, and why a streaming component in an architecture is generally a good idea from both a resilience sort of perspective, but also from a cost optimization perspective as well. And so, yeah, I would say that's the biggest thing. It's the education piece. I think when streaming architectures become more and more normal, that problem will solve itself. But who knows how long that's going to take. So
you said pros and cons. What are some of the cons? Are there times when it doesn't make sense to do streaming?
So speaking from a sort of in the past, I would say introducing a sort of streaming component assumes that you're comfortable with eventual consistency. You've got like a series of events piled up, and you have to just chew through them at the speed that you can. And sometimes there are systems where, and also that you can assume the precedence of the data that you've got. So like first come, first served is a reasonable model. That might not be the case. For example, if you've got the price of something constantly changing, you don't want to queue those things because it's the latest price that is the most relevant. You don't want to process any of the previous prices. And so you can get around that with different solutions, but a basic queuing model in that case wouldn't really work for you. So I think it's possible to build any architecture efficiently using a streaming model. It's just about there are certain nuances that appear that you have to kind of be very aware of, depending on your industry, depending on your engineering challenge, depending on what you're trying to achieve. Luckily for like logs and metrics and things, most of the time it's about the story of what happened. It's not just about like what is the latest current CPU of this box. It's what's been the trend in CPU over the past hour. Where's that spike come from? Those are the more common questions that one tends to ask, and therefore eventual consistency models work really, really well for that. We actually do have some rapid update functionality in the architecture as well, but those are like additions to there's some of those nuances I talked about essentially.
That's really interesting, because I remember earlier you were saying, oh, it's not just like logs, but it's observability and metrics, and I don't think that like quite got into my head until you were starting to talk about CPU, and then my brain went like, but that's not how would you get that from a log? So yeah, it is. That is like a nice intersection.
Yeah, it's the whole whack. It's logs, metrics, tracing, and security. We started life in 2017 as a company, and we were primarily log analytics. And our big sell back then was that we could use machine learning to process logs. We could cluster them together. We could find trends and variances across different values. So, for example, we could look at the normal flow of a certain log from a certain application and alert you when you deviate from that normal flow. And those were some of the earliest sort of differentiators. Now it's a much more sort of full, larger platform that's all kind of caters around the as they say, the three pillars of observability: logs, metrics, and traces. and then security as well. We have a security offering for SIEM, CSPM, and then we have a sort of managed services thing on the security side as well. We'll do like vulnerability scanning for you and things like that. Yeah, and this is what I mean. I think one of the things that people do is they, with the metric side of things. So if you think about a typical metric solution is like Prometheus, maybe you're sophisticated and you've horizontally scaled Prometheus using Thanos, and you've got that deployed across multiple clusters or something like that. And almost immediately with Prometheus, you run into the problem of like all of these nodes are running out of memory, like straight away, like before you do anything, all of the nodes have run out of memory. And then, and this is why I quite like A, streaming architectures, and B, how we leverage S3. So we actually have a system for storing metrics in S3 and querying them absolutely blazing fast. It's really, really quick. But because it's S3, it's much, much, much cheaper than holding things in RAM or holding things in, stalled threads. I saw the other day people using CPU for storage. It was the craziest thing I've ever seen in my life. It was like the worst of all worlds. It was more volatile and more expensive. But they were just someone doing stuff because they can. But yeah, so it's cheaper than RAM, far cheaper than SSD storage, far cheaper, even cheaper than most magnetic storage. S3 is by far the cheapest way of doing it. Problem is the throttling and the query limits, and we've kind of worked out quite a clever system for getting around that. So we can lift, I think one of our query things is about 10 terabytes of data from S3 in about 10 seconds. It's pretty awesome. And that's actually archived data in Coralogix. It's super fast, super powerful.
I'm really curious. Can you talk about how you query S3 so quickly, or is that a trade secret?
No, so I can talk a little bit about the. So we contribute heavily to a project called Apache Arrow, which is all about columnar data formats.
I know that one. Yeah.
So we contribute to that. We use the Data Fusion query engine, it comes down to using a clever format. So we use a slight variant of Parquet called CX data, Coralogix data. So those things optimize performance. Those things make things quicker. And then it's a great deal of parallelization, essentially. A great deal of utilizing serverless infrastructure, issuing a lot of parallel requests at S3. Because the one thing S3 is, it's very, very consistent at high parallel scale.
Yeah.
But it doesn't allow these massive one-off queries, or it doesn't perform particularly well on those. It usually batches them, and you end up having to do lots and lots of them in a chain. So we utilize a great deal of parallelism to pull up a huge amount of data. And then we have a custom language called DataPrime. DataPrime is a data analytics language. And the real sort of beauty of it is that it allows, you can do like data discovery. So you can kind of process and change, you can aggregate data in stream. So for example, you can pull out data and say, tell me the top 3 availability zones that have the most logs coming from them, to give you an idea of activity coming from your different availability zones for balancing. You can do that on the fly, and it will aggregate the data on the fly for you. All of that is enabled by essentially just a huge amount of parallelism, coupled with a great deal of cost optimization built into things like AWS Lambda and Fargate and things like that. So we kind of just pay for usage and nothing more. And yeah, I think that's a fair summary.
That's really cool.
Yeah,
I wouldn't have thought of all that. That's pretty sweet. I recently had the privilege of interviewing Matthew Topol from Voltron Data, who works on Apache Arrow on a different podcast. And it was, I mean, I didn't know about the project until then, and it was quite fascinating to hear how that works. And
it's awesome. It's awesome.
Yeah,
like it certainly wouldn't be my area of expertise, but we have some engineers in the company who they talk to me about this stuff, and I'm like, sure, yeah, absolutely, like. Great, sounds fantastic. Like, and I say that as a 10-year engineer. I have a clue about like 35% of what they're saying, and then they just lose me. They start talking about I was never good at data structures and algorithms. It's never been my never been my topic. But those guys are hot on it. They're really, really good at it. So yeah, it's a great deal of computer science going on at Coralogix actually, which has been a nice but somewhat haunting refresher of my degree.
If anybody's interested in listening to that episode, by the way, it's the Cup of Go podcast, the episode from February 13. If anybody wants to hear that interview with Matthew Topol, just for the listeners who might be interested.
I wanted to ask, what's the onboarding process like? If I have an existing logging solution from some unnamed other party, what's the transition look like to switch over to Coralogix?
Yeah, so it obviously it depends on the tooling you've decided to utilize in the first place. But there are a few key things about our customer service. One, we offer free onboarding. So if you have an account, you can go straight to customer support and say, "Hey, I need help integrating with Coralogix." In 15 seconds, you get a response. Usually, very very shortly after that, you'll get an engineer, and the engineer will sit with you and work with you to sort of install software in your cluster and deploy things as needed. If you have installed anything like FluentD, FluentBit, OpenTelemetry, um, FileBeat, any of the really normal open source solutions, Prometheus, OpenSearch, then it's just a matter of shifting a bit of config, and you will natively integrate with all of those things. We natively integrate with like all the cloud provider metrics, just like CloudWatch and AWS, for example. We have like Firehose integrations, direct integrations with CloudWatch, Lambda. We have like a Lambda layer, which will automatically export your CloudWatch metric, all sorts of different stuff. So obviously it depends on your tech stack in terms of the actual technology you'll employ, but you'll do all of it with an engineer who spends all of their time helping people integrate. And so you'll do it with an expert, basically. And that's one of the things that I personally am quite proud of talking about, because I've seen this functionality develop in the company, and how they've trained the people, how they train the engineers on the job, and seeing the impact that it's made to customers on board into the platform is awesome. So the onboarding journey is super smooth because you're not really doing it on your own. There are, as we say, sort of people that just sign up, start a plan, do their own thing, and they're quite happy. We have a bunch of documentation. There's a great deal of me speaking, because I make all these videos that are embedded in the documentation. So I imagine somewhere out there are a series of people who are sick of the sound of my voice. But maybe you guys by the end of this podcast, we'll see. So it's embedded in the documentation, and also the platform itself has all these nice little tooltips. You hover over something and it'll tell you all about it. With cheat sheets buried everywhere for people to use. So yeah, and we have native integrations to like 200 different tools. So the chances are, if you use it, we integrate with it. So it's pretty smooth at this point, from both a support and an engineering perspective.
Yeah, I do have to say, as a Coralogix user, like the in-app tooltips and help menus and links to documentation is actually really, really well done, which is hard to do in an application of that scale. And there's numerous examples of seeing it done incorrectly, but inside of Coralogix, it's pretty intuitive to get where you need to be and get help for the things that you may not understand once you get there.
That's awesome. I'll definitely make sure the feedback gets back to the engineers and the product guys. They are great. They actually agonize over that stuff a lot. So every time there's a new feature discussed, the big conversation is, how cohesive is this with the other features? Will this confuse people? And then obviously there's an old phrase. What is it? There's only two hard problems in computer science: like caching, validation, and naming things. And the naming things is, we really agonize over it. Like there's 200-300 message Slack threads like, no, that word doesn't make any sense, and it goes on and on and on. We really do spend sweating the details on that, because it makes a material difference to the experience that the customers have. So yeah, it's awesome to hear that. Thank you very much, Will.
Naming things is terrible. I agree.
It's a real source of stress. I don't like it. Because there's always somebody with a better vocabulary than you as well, who's like, did you think to use this word? And I'm like, no, I didn't think to use this word. Great. Thank
you. Walk with thesaurus, as you? No.
Yeah. Yeah. Or when engineers typically use, like, they'll use very, very niche words that are technically correct, but you need to use a dictionary. It's like C++ programming and then a dictionary on top of it, just to make sure that you can keep up with whatever. I learned a word, munging was the very first word, my very first role in software engineering, and I was like, what does munging mean? What is that a verb? And then it turns out it's like merging two things together, and it's sometimes used in data, and I never knew this. Like, that's the worst sounding word I've ever heard. I've never heard that word used ever. Like, not joining or merging or anything that everyone knows about munging for some reason. But when you actually look at the definition, it's precisely what it was doing, like exactly what it was doing. So you can't argue with the correctness, but yeah, the usability of the word somewhat lacked.
I've always felt like munging was this word that saying the word kind of describes exactly what it's doing once you know that.
Yeah. Yeah. All of this I agree with, and that didn't stop me from spending like 2 weeks as a brand new software engineer, frantically trying to work out, is it this kind? What does munging mean? What is munging? And not wanting to ask anyone because I just assumed everybody else knew.
What's the algorithm for
half of
munging?
core
I don't want to
had
get
no
it
idea.
wrong.
Right.
Yeah.
Or as the new guy, you're like, these guys are screwing with me. They just made that word up.
Yeah.
Yeah.
Reminds me when I was a waiter, we would tell new hires to go to the basement and find a can of steam.
Oh yeah.
When there was no basement, and what's a can of steam? Come on.
Yeah. we used to tell. So this was back when I was a bartender a long time ago, maybe 11, 12 years ago now, and yeah, if we ever got new people in, it would always just be like, what was the one? It was like, can you go get the non-alcoholic vodka from the back? And they go into the back and they'd be there for ages just hunting around for non-alcoholic vodka. And then they come out to the front and be like, I can't find any. And it'd be like, you spent 45 minutes. What were you doing? And they've been through everything. Like,
the customer already left.
Yeah. Brilliant.
So what kind of tips can you give to us that like streaming logging or just logging in general, like that's the back end of it? What kind of tips can you give us to make your logging better or more useful? Like what kind of application side things can or should you be doing?
Yeah. So look, if let's say you go with like a build your own kind of DIY, pretty typical stack, so like OpenSearch for logs and Prometheus for metrics and stuff. I think there are some pitfalls that everybody does, and I consider them. I said one before, which is the typical model is hold the data in Elasticsearch, for example, for 2 weeks and then archive it. And like I said before, the problem with that is it makes the assumption that if you just hold on to data for long enough, at some point it'll become useful. And so that model, I think, is an anti-pattern. If it's useless at day 1, the chances are that it's not going to be useful at day 14. And so you've just spent 2 weeks worth of money essentially, and it's not a huge amount per log, but it adds up really, really quick. And when you add onto that the overheads of maintaining a large cluster and operating these sort of extremely complex OpenSearch clusters is a skill into itself. That'll be the first thing. So as a general heuristic, it's keep as much data as possible out of your OpenSearch cluster. Like don't think that everything needs to go in there. Try and use your high performance storage for your things that you really, really need. So error level logs and things of that nature, really, really important stuff. And try and find another low cost place that you can hold stuff. So one example that people have used in the past that we've seen is store it in S3, index it into a Parquet format, index it using like AWS Athena, for example, and query it that way. AWS Athena, the queries will take maybe 30 seconds, 40 seconds, sometimes a lot longer if you've got a lot of data in there. And that's where it gets really the limits of this theory. But try and find ways of cost optimizing early and build that into your architecture, because otherwise you're going to rapidly run into some problems, especially around performance, but later on down the line around cost. And then in terms of for a sort of, we'll go up the stack a bit. So in terms of your infrastructure, try and find the lowest touch maintenance tools that you can, because maintaining them is just going to be a freaking nightmare, and be ready to trade off on some features for that. In my experience, especially on the collection side, you don't need super fancy, can do all singing or dancing sort of agents and things like that. 9 times out of 10, you're going to use the most basic features in them and hopefully never think about it again, except the odd patch that you've got to do, when there's like a log4shell update or something you've got to panic about. And so I'd strongly recommend open source collectors, even if you're using a SaaS vendor. Open source collectors, definitely. It gives you more purchasing power. If you don't like the vendor you're with, your code isn't absolutely littered with their code, so you can go and change. You can just switch config and move to somebody else. But also because they're usually better. They're more well maintained, longer lived, battle tested. There's no weird memory leaks. They perform more reliably. And then if we go up the level again to the code level, I would say try and include as much metadata as possible into the log documents themselves. So don't just have a log that's like hello. Obviously, log in like a JSON format. Make sure it's a machine readable format that's nice and easily indexable, and then include lots of metadata fields in that log. So what that does is it means that your data can be sliced from lots and lots of different ways. It improves the cardinality of your data. what this in turn does is it means that your data can be analyzed in lots and lots of different ways. And it's actually the thing that tools like OpenSearch are really, really good at, is dealing with high cardinality data. So those would be sort of three of the stack sort of tips that I would say. There's obviously a whole dark art to sort of getting this stuff right, but really be aware of the three major sources of cost: is storage, holding onto all this stuff; compute, keeping your queries fast; and the third one is the operational and overhead of just keeping this thing alive once it's big enough. Those are the three places where the cost is really going to get you. If you go with your own build your own solution. With a SaaS world, I would say it's all about the overages that you want to avoid. To be really, really aware of what data you're sending and making sure that your deal is reflective of the actual usage of your data. That's something we see a lot with people who've come over to us from other companies. Is they say, well, our base amount was, let's say it was $100,000 a year, and we kept getting overages of $300,000 a year. It'd be like, well, what was your base deal? And then you look at their base deal and it's like, well, your base deal was a quarter of what you actually sort of use. So, this was always going to happen. This was always like, your true cost was always going to be $400,000 a year. It's just that for some reason it's been divided into a base cost and an overage. And so we find that that's the kind of stuff, especially with SaaS providers, that you need to be aware of. Make sure your bill is really, really good. Make sure their support is good as well, because there's nothing worse than leaving a ticket for a week and a half and wondering whether anyone's listening to you on the other side, especially when you're paying a lot of money. Those are just some of the things.
Cool. I'm wondering, what kind of machine learning models are you guys using? What is their purpose? I know you said something like whether or not a log is important. Is there anything else?
So there's a bunch of stuff we do. We do anomaly detection. So we have machine learning models that are detecting flow anomalies. It will, if for example, at 3 p.m. on a Tuesday, you typically are receiving, 100 error logs. The Coralogix platform will learn that is your normal profile, and you can set an alarm, which is essentially like if I get more than usual at any time, over a certain amount, so I get 1,000 more logs than I normally expect, tell me about it. And so that's one of the machine learning aspects that we have. What that enables us to do is it answers the quite complicated question of dynamic alerting. So static alerting would be, tell me when I have more than 1,000 errors, or tell me when I have more than 4% errors. But maybe for your platform on a Friday at 4 p.m., 4% error rate is actually okay, because you have so much traffic, because it's Friday at 4 p.m., that 4% is tolerable, for some reason. And so what we say is you can set a more than usual alarm, and you say, actually, what I've had this week, that's good. Let's roll with that. And then next week you get 8%, you'll be told about it. And so that's one of the ways that we utilize machine learning. Super powerful. What we often recommend is that is kind of like your catch-all safety net at the bottom of all of your alarms. That's the thing that's going to catch the weird stuff you didn't consider, the unknown unknowns, as people often say. And then you can define more traditional alarms around more static thresholds higher up, where you can say, well, if this exceeds this, or this exceeds this, or whatever. And that way you have a lot of known problems that you can cover with alarms, and then this nice sort of safety net underneath all of it using machine learning. And the second thing, there's a bunch of different examples, just two that immediately come to mind. The second one is clustering the logs together. So you've got, you run how many errors have I had in the past hour? 250,000. It's like, great. What do I do with that? Like, how do I dissect 250,000 alarms? One of the things that we found, we run like sort of meta-analysis of how customers are using the platform. And one of the things that we found is that 95% of all errors in a customer's data set are caused by the same 5 problems. So 95% of all alarms, error logs, everything are all from the same 5 root causes. So we use something, a tool called logregation, or it's a feature called logregation, where it will cluster your similar logs together. So if you have 200,000 error logs that look almost identical with some minor variations, it will group all them together, and you can click in and see, well, this is the normal flow of this type of error log, and this is what you're currently seeing superimposed on top. And likewise, you can click on each individual field, and you can see, well, for this field in a log, for this key in a log, for example, kubernetes.host, here is the number for this host, here's the number for this host, here's the number of logs that came out of this host, and so on. And the power of that is that rather than scrolling through and being like, okay, I think that 2,000 of them came from this host, so maybe that's a place to investigate. You just skip all of that. How do you construct that query stuff, and you get straight into the, okay, it's 2,000 from this host. Sweet, this is our starting point. That's a problem. This host is broken. So yeah, those are two ways that we utilize machine learning. Like I say, that was the original thing that made us differentiated us back in 2017, well before my time at the company. I think it was like a 3-person company back then. Now it's 250, so scaling quick.
So is it safe to say that you munge those logs together?
Oh, absolutely. 100%. Nice use of the word munge, by the way, Will. I like it. It's good.
If nothing else, I'm good for comic relief on the podcast.
This is really cool. I don't really think I have any other questions, though. Is there anything else that you wanted to add, or anything that you didn't get to talk about?
No, all good. Happy to some great questions there, so thank you very much. But yeah, all good otherwise.
Shall we go to picks?
I think we should do some picks. All right, so my pick this week, I'll just jump right in. David Goggins, if you aren't familiar with him, he is a Navy SEAL, ultramarathoner, just has a pretty incredible backstory. He released a new book about a month ago called Never Finished that kind of picks up where his first book left off, and it talks about continuing his ultramarathon career and his quest to become a smoke jumper, which a smoke jumper is someone, a wildland wilderness firefighter that jumps out of the plane into the backwoods and fights the fire from within and works their way out. And so it's his quest to become that. It's a really cool book, very inspirational and motivational for me anyway. So if you like that kind of stuff, Never Finished by David Goggins is a great book. And I read the book, but I've also heard that the audiobook is really, really well done because he's actually in the recording booth with the narrator and then adds a lot of colorful context that's not in the printed copy of the book.
When you said it was called Never Finished, I thought you were talking about my personal life and how I never get anything done.
Right. It's like, wait, David Goggins is a Scrum Master now? That guy can do it all, man.
Well, I can go
If he was
next.
the Scrum Master for the team, I would. That would be terrifying. Absolutely terrifying. It'd be great. I'd get more work done than ever, but I would. Yeah, the stress would be intense.
Yeah, you'd be closing tickets just out of sheer fear.
Yeah. God.
All right, so my pick for this week, actually, I have two related picks. The first is a book I'm close to done audio reading. It's called A World Undone, The Story of the Great World War, 1914 to 1918. So it's kind of a all-encompassing history of World War I. And the author starts out by explaining that, there's been a lot of books and movies and other stories about World War I, but they're usually very narrowly focused on a particular battle or a particular person or a country. So this book tries to sort of be all-encompassing, explaining what led up to the war for from the assassination until the war actually started a couple months later. So it's really fascinating. But one of the things that, and it's long, it's like the audiobook is 27 hours or something like that. So it's a long book, as you could expect for a book that tries to be all-encompassing about such a big topic. But it's a really good book. But it's also such a sad story. And I don't just mean sad because war is sad, because war is sad, of course. But so often throughout this war, both sides made horrible, horrible, terrible mistakes. Like assuming that they could just charge the enemy and with enough willpower they would break through the front lines, or ignoring warning signs that the enemy was advancing, or just whatever. Just terrible, terrible, terrible mistakes. I'm sure that happens in all wars, but it's just terrible how many, you read about a battle, 80,000 people died because the two people in charge made stupid mistakes.
Yeah.
And so that leads to my second pick, which is going to be any English translation of Sun Tzu's Art of War. If any of these people had read that book, World War I probably would have been a lot shorter. So those are my two picks. A World Undone by G.J. Meyer and Sun Tzu's Art of War.
I've always been amazed at sort of like the human psychology of war. Like, how does this work? I'm going to convince thousands of people to just go run towards death, like that way, go that way. How does that happen?
Drugs, mostly, and alcohol. Was the weapon of choice for World War One. Certainly World War Two. Almost all wars that after the brewing of beer was pretty much. It's amazing actually. So I'm a bit of a history fan as well. Big fan of British history, and there's an endless set of examples in modern war, Renaissance war, in antiquity, even when the British were fighting the Romans, everything where we consistently messed up strategies because we were absolutely wasted while we were trying to conduct like 10,000 person formations and things, and we're just falling all over ourselves. And it's genuinely fascinating how, and in World War One, World War Two, how much amphetamines like played a role. It's basically just like, here, take this. You feel really good, and I run that way. Like, ignore the bullets, enjoy yourself. It's crazy how much that it's sort of got people going.
So it's a bar fight at scale, is what you're telling me?
Yeah, essentially, yeah, for sure. Especially World War One. World War One was our first attempt at truly industrialized warfare. Like before then, it was the Napoleonic Wars, right? And that was just not even the same kind of. We weren't even close to that kind of scale, of that kind of technology that was being employed. And so the idea, like you mentioned that the generals that were like, if we can just beat them with willpower. It's like, yeah, kind of. I think during the Napoleonic War, we started to realize that willpower was less useful than particularly well organized troops and superior technology. But it was the technology thing just hadn't quite landed there because guns and weapons and bombardments were still so temperamental. Whereas now First World War, of course, that becomes they're really reliable. They're really, really efficient, really reliable. Like,
all right, well, I'll go next. I'm going to pick the third season of This Dark Materials. It's on Hulu, and I normally don't like book to TV adaptations, but I did really like this one. I don't know. It was really good. It stayed pretty true to the series, I thought. And I had something else too. Oh, I'm going to give my usual disclaimer. Don't watch any of it if you cry easily and you have stuff to do that day. Like, just don't do it. That's my pro tip.
I guess I won't be watching that one then. I cry very easily.
His Dark Materials has me crying like a little girl. Like, it's not okay. And then my kids come and like troll me about it.
Oh no!
Would you watch Mom, the Little Mermaid?
Oh
no, I didn't. It's something else making me cry today.
It's horrible.
All right, Chris, your turn.
I'll try not to cry. So I would pick two. The first is a book by General Stanley McChrystal, which is called Team of Teams, which is a fantastic book all about where command and control should sit in any kind of scaled organization of people, how much sort of localized and independent decision-making teams should be able to make. Certainly when I was principal engineer in a previous life, and there was a few hundred people that I was partially responsible for helping to organize in some form. It was a very, very good guidebook on backing off and letting people do their thing, and encouraging people to be able to do their thing rather than me being the sort of composer or orchestrator all the time, which was certainly the first instinct. So really great book. Strongly recommend anyone reads. If anything, because General Stanley McChrystal was the guy that completely changed the nature of the war in Iraq against Al Qaeda. So he was the one that turned it from American essentially losing people left, right, and center, and constantly losing skirmishes and really poor intelligence. He was the one with some of the ideas that he details in the book, turned that into really, really efficient intelligence supply lines, and incredibly collaborative teams that were spanning tens of thousands of people with disparate missions, disparate goals, sometimes conflicting goals, and somehow made that into a sort of reconciling system. Absolutely remarkable. So really, really great book. The second is a book that I've just finished rereading, Don Quixote, which I think is the first modern novel ever written. But it was by Miguel de Cervantes, and it is generally just an affirmation of doing stupid stuff is sometimes good. So just do it anyway, and live in your own fantasy for a while. Why not? Like, be a bit delusional. It's good for you. And that's the thing I take away from the book. I strongly recommend it, especially if you're feeling like you're embarking on some stuff and you need someone just to tell you to take the risk and give it a go. It's a long book, it's like 1,000 pages, but it's great, awesome. Like, you finish it and you feel like you take this whole new perspective, much more optimistic outlook, and ultimately that's what the book's about. So yeah, those are my picks.
Right on.
Very cool. I agree that Team of Teams is an excellent book. It's one of my favorites.
Well, cool. I believe we have a podcast.
We do.
I think so.
I guess I control the button, don't I? I have to hit stop now.
Yeah.
All right, here goes.